All right, let's talk about radical equations. So the way I'm going to start off with is talking about the steps first. All right, so steps to solve radical equations. Okay, so step one is to get a radical by itself. Okay, so the reason why I have A is because majority of the equations you're going to be solving is only going to have one radical, but sometimes there will be two radicals in there, and we will have to get one of them by itself, and that will be the last example I do just to show that. Okay, step two, we're going to raise both sides by the index. And you guys remember the index is the number that's in the wedge. All right. Step three is to solve. And step four is necessary in this chapter is to check your solution or solutions. Okay. So let's start with example one. All right. Example one is this. Let's start with the square root of 6x minus 5 minus 3 is equal to 2. Okay. So that minus 3 is not under the radical. The radical ends at the 5. Okay. So step one was to get the radical by itself. So I have to add 3 to both sides. So I'm going to have the square root of 6x minus 5 is equal to 5. Then I'm going to have, well, before I even say that, remember that when I look here, I see that the index is a 2, okay? Because it's a square root, there's no other numbers in the wedge, so therefore the index is going to be a 2. So what I need to do is raise this side and this side to the second power, okay? So here I got the square root of 6x minus 5, and this side I have 5. All right. So therefore, on the left, I'm going to have the square root and the square root are opposite operations, so they kind of cancel each other out. So that's what I have, because 5 squared is 25. The square root of 6x minus 5 squared just gets rid of the radical, so therefore now I don't have any more. Now I just solve for x, which is step 3. So I have to add 5 to both sides, so I'm going to have 6x is equal to 30. So therefore x equals to 5. Okay? So before I box that answer, however, I do need to check that. Okay? And every time I check, I need to use the original equation. Okay? So which means, so when I use the original equation, I have the square root of 6 times 5. Ooh, that's an ugly 5. Let's try that again. 5 minus 5 minus 3, and see if that equals to 2. All right, so what do I have here? I had the square root of 30 minus 5 minus 3. Is that equal to 2? 30 minus 5 is 25. Square root of that is 5. So it's 5 minus 3 equal to 2. And the answer is yes. So therefore, I can accept this as my solution. Okay? Now, the reason why I say, on step 2, raise both sides by the index is because I'm not always going to be solving for square root problems. All right, so I might have a cube root problem. So let's do an example like that. So example 2. So example 2, let's call it the cube root of x minus 7 minus 3 is equal to 0. Okay, so step 1 was to get the radical by itself, so that's what I'll do. To add the 3 to both sides, so I have that. Then, and I know that my index is a 3. Okay, so now I need to raise this side and this side by a power of 3. So over here I have the cube root of x minus 7 and this side a 3. So when I raise the left side to the third power, the cube root to the third power is just going to drop that radical, so I'm left with x minus 7. And the right side is 3 cubed. 3 times 3 times 3 is 27. Okay, so therefore I have x is equal to, add the 7 will be 34. So before I box that, I do need to check it. And I always have to use the original. So okay, so I have the cube root of 34 minus 7 minus 3 and see if that's equal to 0. Okay, so 34 minus 7 is what? Correct, it is 27. So I have the square root, cube root of 27 minus 3 and see if that's equal to 0. What's the cube root of 27? So index is a 3, so I'm looking for 3 of a kind, all right, a group of 3. So 3 numbers multiplied together, that would give you 27, which would be 3 times 3 times 3. So the cube root of 27 is going to be 3 minus 3. Is that equal to 0? And the answer is yes. So therefore I can box this answer and say that is my answer. Okay, and there are times that it won't work, so just be careful. All right, so let's take a look at another example here. I'm at example 3, so let's see here, example 3. All right, so let's say I have the square root of 9x, what did I choose here, plus 18 plus 9 is equal to 0. Okay, so get the radical by itself. So I have the square root of 9x plus 18 is equal to negative 9. My index is a 2 because it's a square root. So I need to raise this side and this side to the second power. This side is going to be the square root of 9x plus 18, and this side is going to be the negative 9. So the left side, the square root and the square, cancel each other out. So I have 9x plus 18 is equal to negative 9 squared is 81. Okay, so I got to subtract the 18, so I got 9x is equal to 63. So therefore x is equal to 7. So before I box that, I need to check it. And I always have to use the original to check it. All right, so let's see. I have the square root of 9 times 7 plus 18, and then add the 9 and see if that's equal to 0. All right, so what do I have? I got the square root of 63 plus 18 plus 9. Is that equal to 0? 63 plus 18 is 81. Square root of 81 is 9. So I got 9 plus 9. Is that equal to 0? And the answer is a big fat no. All right. So that's definitely not true. So I can't use a 7, and that's the only answer I have. So I have to reject this. So therefore, my solution is actually no solution. Okay? But here is the thing. I should already know this answer was going to be rejected, that there was going to be no solution. And you're going to be like, why? So here is why. So this line right here, okay, says the square root of a number is going to equal to -9. So is there ever going to be a square root of any number that's going to give you -9? And their answer is no. There's never going to be square root of a number that's going to give you -9. So that would be dead giveaway right there, okay? So I would have known at that particular time that I have no solution and that would already been done, all right? But in case you forget that and you go through it and you check your answer, you're gonna find that out as well, all right? So, I said this part right here on step 1, get a radical by itself. So let's talk about what that means. So example 4 is going to be long. All right, example 4 is where there is going to be 2 radicals in the equation. So something like this, the square root of 2x minus 1. The square root is too long, so I'll do it this way, plus the square root of x minus 4 is equal to 4. Okay, so step 1 says to get a radical by itself. Doesn't matter which radical you get by itself, it does not. I like to usually take the simpler one and move that one. Okay, so I want to keep the more complex one, so I'm going to keep this one on this side, and I'm going to move the square root of x minus 4. Well, it's positive, so I'm going to subtract it over to the other side. So it's going to equal to 4 minus the square root of x minus 4. Okay, and what's the index again? That's right. Oops. Index. All right. So let's try to spell index right. That is a 2. That's correct. So I have to raise both sides to the second power. This side is going to be the square root of 2x minus 1, and this side is going to be 4 minus the square root of x minus 4. All right? The left side is easy. The right side, even notice, is a binomial squared, which means we have to, that's right, we have to FOIL this. Oh boy. All right, so let's do this. I'm going to show it to you this way. So the left side is just going to be at 2x minus 1 because the square root and the square root cancel each other out. No big deal. Okay. The right side, I'm going to do in 2 markers here. This is going to be the 4 minus square root of x minus 4. I'll use green. Times 4 minus square root of x minus 4. So yes, I either gonna have to FOIL or double distribute. Okay, I would tell you to double distribute. I think that with radicals is a lot easier to see with double distribute rather than FOIL. So if I use double distribute, this is what it will look like. I'm taking the 4 and distributing it into that second parentheses. And taking the negative square root of x minus 4 and taking that and distributing into the second parentheses. All right, let's see what that gives me. So I have 2x minus 1 is equal to this is going to give me 16. This is going to give me a negative 4 square root of x minus 4. Remember, these two can't multiply because the negative 4, the 4 is on the outside and the x minus 4 is on the inside of the house. So therefore, it's no good. All right. And then I have this one here, which is negative 4 square root of x minus 4. And then let's bring some blue in here. And then this right here is going to be a positive x minus 4, okay? So what I really have is negative times negative, which is positive. I got the square root of x minus 4 times the square root of x minus 4. So essentially it's square root of x minus 4 squared, right? So that's why the radical will kind of go away. I'm left with just the x minus 4. All right, so the next step, I'm going to do some combined like terms, CLT, combined like terms. All right, let's rewrite this in combined like terms. So I have 2x minus 1 is equal to, I have, let me see, like terms here. I got the 16 with the negative 4, right? I have, let me see here. Let's use the blue. I have this right here with this right here. And then I have the x. We all see that? Okay. So let's write it out. So I have x plus 12 minus 8 square root of x minus 4. Okay, so I got the x. The 16 minus 4 is 12, positive 12. And then the negative 4 minus 4 will be negative 8. Okay, so here is where it comes into play. So I still have a radical. So if you notice the previous examples, every time I got the radical by itself, the next step, after I raise each side by the index, what happens? The radical goes away and I start solving just an equation that has no radicals in it, right? So over here, I still have a radical, so I'm gonna do the same thing again. So I'm repeating step 1 again, repeating step 2 again. So before I even get to step 3, I gotta repeat steps 1 and 2 over and over until the radical is gone, okay? So with that being said, I'm going to subtract the x over to the left side, and I'm gonna, or I should say, bring the x over to the left side and bring the 12 over to the left side by subtracting it. And when I do that, I'm gonna have a x minus 13 is equal to negative 8 square root of x minus 4, okay? Now, I do not need to get rid of the 8. Yes, the radical isn't necessary by itself, but I can actually do this because I know this rule from exponents. So if I had a times b raised to the nth power, that is equal to a to the nth times b to the nth. Okay, so I can do that, all right, because it's multiplication, all right? So we gotta remember that. So from here, I can start with step 2, get into step 2, which is raise both sides by the index. And what I also know here is that index is still a 2, okay? So I gotta raise this side to the second power and this side to the second power. So over here, I got the x minus 13. On this side, I got negative 8 square root of x minus 4. Okie doke. So, geez, what do we have to do on the left side? Don't we have a x minus 13 times a x minus 13? So I have to FOIL here, right? And the right side is going to be a negative 8 squared times a square root of x minus 4 squared. That's what I actually have, okay? So the right side I don't have the FOIL because I have this rule right here. I want you guys to understand that. I got this rule right here, and that's the rule I'm applying there, all right? And on the left side is a binomial square, so I have to write it out twice so I can go ahead and FOIL it, okay? So what do I have? I'm going to have here on the left side an x squared minus 13x minus 13x plus 169, which is 13 times 13 is equal to 64 times x minus 4. So negative 8 squared is 64, and then the square root of x minus 4 squared, square root and squared, opposite operations, okay? So that drops. So the left side, I'm going to combine like terms. So I'm going to have x squared minus 26x plus 169 is equal to, so let me do it this way. So I got combined like terms on this side, and on the right side, I'm going to distribute. So the right side is going to be 64x minus 256. All right, so now I can solve. Oh boy, look at this. I see an x squared and an equal sign. What does that mean? Ooh, quadratics, that's right. So I'm gonna, with quadratic equations, I gotta get everything to one side, so I have a non-zero side and a zero side, right? So here we go. I don't have any x squares to bring over, so I'm just left with x squared. Bring the 64 over by subtracting it, so I got negative 26x minus 64x, and I'm going to have a negative 90x. I'm going to add the 256 over, so I got 169 plus 256. I'm going to have a 425 is equal to 0. So you got a couple of choices. You can, well, right now, as of right now, you're going to be using just factoring because you haven't gone through completing the squares or quadratic formula yet. So you actually have to factor this via AC method. And when you factor this via AC method, what you're going to get is, you're going to get x minus 85 times x minus 5 is going to equal to 0, right? Because negative 85 times negative 5 gives you 425. Negative 85 plus negative 5 is going to give you negative 90. All right. So now I have x is going to equal to 85 and x is equal to 5. So question is, can I use them both? So what do I need to do? I need to check. All right. And I feel like the original equation was so far away. So let me put down check over here. And let's look for that original equation, which is all the way up here, right? Ooh. There we go. Let me bubble that in so you guys can see. All right, so now I gotta do all of this at once. All right, so let's do the 85 first, okay? So I'm gonna have the square root of 2 times 85 minus 1, which is square root of that, plus the square root of 85 minus 4. That's the square root as well. And see if that equals to 4. That is a big fat question. Right? Is that true or not? So let's go through it. So what I have here is that 2 times 85 minus 1. 2 times 85 minus 1 is, of course I need to check that. Hold on. All right, so 2 times 85 minus 1 is going to be 169, plus the square root of 81. Is that equal to 4? So square root of 169 is going to be 13, plus 9. Is that equal to 4? Heck no. So therefore, I have to reject that one, because I know that that's not equal. Now I got to do the same thing again with the 5. Okay, so let's try that. So essentially I'm going to have the square root of 2 times 5 minus 1, square root of that, plus 5 minus, oops, let's try it again, minus 4, that square root as well, and see if that's equal to 4. Big old question mark. Right? All right, let's see. So 2 times 5 is 10, minus 1 is 9, so square root of 9, plus 5 minus 4 is 1, the square root of 1, and see if that equals 4. So I have 3 plus 1, is that equal to 4? Yes, right? So therefore, this is the only answer I have. All right. Now notice how much longer that problem is versus those problems. So this almost fills the screen right here, and it kind of fits almost 3 of these problems into that one. All right. So, but I hope that this helps. And if you have any questions, you know how to get a hold of me, and you'll have this video, and you'll also have the PDF notes, and I'll see you guys.